Good morning. I am Mrs. J.P. Suchitra from Dr. MGR Educational Research Institute. Now I am going to explain instruction set of 8085. So instruction set of 8085 is a binary pattern designed inside a microprocessor to perform a specific function. So the entire group of instruction that the microprocessor supports, it's called as an instruction set. So instruction set has 246 instruction. So each instruction is represented by an 8-bit binary value. So these 8-bit of binary values is called as opcode or instruction byte. Classification of instruction set. Here you have 5 types of instruction. One is data transfer instruction, second one is arithmetic instruction, third one logical instruction, fourth one branching instruction, fifth one is control instruction. First one we are going to see, that is data transfer instruction. So these are the instruction which is used to move data between the register or between memory and the register. So these instructions copy the data from the source to destination. So while copying the instruction, the contents of the source are not modified. So first one is in this type of instruction you have 3 contents. One is opcode, another one is operand, then one is then description. That is, opcode and operand must be present in the data transfer instruction. So opcode is nothing but MOV, for example MOV, move. Then operand is read, reset, memory, and then memory. Okay, so the description is nothing but copy from source to destination. So this instruction actually copy the content of the source register into the destination register. So the contents of the source register are not altered. If one of the operand is a memory location, its location is specified by the content of the HL register. Example, move B, C. The next data transfer instruction, MVI, move immediately. So that is the opcode. Then read data, memory, then data. This is the operand. The description is move immediate 8-bit data. So that MVI. Then the 8-bit data is stored in the destination register or memory. If the operand is a memory location, its location is specified by the content of the HL register pair. So for example, MVI B, 57H. The next instruction, example is LDA, that is load accumulator. Then operand is 16-bit address. So the content of the memory location specified by a 16-bit address in the operand are copied to the accumulator. The content of the source are not altered. Example, LDA 2034H. So next instruction is arithmetic instruction. These instructions used to perform addition, subtraction, increment, decrement operation. In addition, any 8-bit number or the content of register or the content of memory location can be added to the content of accumulator. Then the result is stored in the accumulator. No 2 other 8-bit registers can be added directly. Example, the content of register B cannot be added directly to the content of register C. Next one is subtraction. Any 8-bit number or the content of the register or the content of the memory location can be subtracted from the content of accumulator. So at the same time, the result is stored in the accumulator. Subtraction is performed in 2's complement form. If the result is negative, it is stored in 2's complement form. Increment or decrement. The 8-bit content of a register or a memory location can be incremented or decremented by 1. The 16-bit contents of the register pair can be incremented or decremented by 1. Increment or decrement can be performed on any register or a memory location. Arithmetic instruction. Example, add. So add is the opcode. Then operand RM. Description is add register or memory to accumulator. The content of register or memory are added to the contents of accumulator. The result is stored in the accumulator. If the operand is memory location, its address is specified by HL pair. All flags are modified to reflect the result of the addition. Example, add B or add M. Logical instruction. So these instructions perform logical operations on data stored in register, memory and status flag. The logical operations are AND or XOR, rotate, compare, complement. AND or XOR. Any 8-bit data or the content of register or memory location can logically have AND operation or XOR operation with the contents of accumulator. Then the result is stored in the accumulator. Rotate. Each bit in the accumulator can be shifted either left or right to the next position. Compare. Any 8-bit data or the content of register or memory location can be compared for equality, greater than, less than with the contents of accumulator. The result is reflected in status flag. Complement. The contents of accumulator can be complemented. Each 0 is replaced by 1 and each 1 is replaced by 0. Branching instruction. The branching instruction alter the normal sequential flow. These instructions alter either unconditionally or conditionally. Branching instruction. Example, JMP. Jump. Opcode. Operand is 16-bit address. The program sequence is transferred to the memory location specified by the 16-bit address given in the operand. Control instruction. The control instruction control the operations of the microprocessor. First one is NOP. Opcode is no operation. Then operand is none. So no operation is performed. The instruction when this instruction is fetched, no operation can be done. The instruction is fetched and decoded but no operation is executed. Example, NOP. Thank you.